Hello and welcome to our next video on the intermediate value theorem. Here is a statement of the intermediate value theorem. We have a function f. It must be continuous on a closed interval. We'll call that ab. And then we have a value n that lives somewhere between f of a and f of b. If these two conditions are met, then there exists a c that lives between a and b such that f of c is equal to n. Now, as so often is the case with mathematics, it's very helpful to have a picture of a graph to see what these symbols mean. So, without loss of generality, I'll call this a, this b. Let's call this f of a and this f of b. And we have some continuous function, at least it must be continuous, as long as x is between a and b. So let's just draw something. So that's my made up f of x. And we are going to pick some value n that lives between f of a and f of b. So let's just randomly pick some number. I'll call that n. What the intermediate value theorem is saying is that if we have met these conditions, there must be some point between a and b on the x-axis. We're going to call that point c, such that f of c is equal to n. So let's just trace out our line here, because every point on that dotted line has a y value of n. And let's see where it intersects the curve right at this point here. If we drop down to the corresponding value in the x-axis, well, we can call that c. And for our example, we absolutely have the results of the intermediate value theorem, where f c lives between a and b, and the point c, f of c, gives a value of f of c, which is equal to n. So that is the intermediate value theorem. And I'm kind of hoping that right now you're saying to yourself, so what? What's the big deal? Well, here's what the big deal is. Let's look at this specific example. We have an equation 4x cubed minus 6x squared plus 3x minus 2 is equal to 0. So this is a polynomial equation, and we want to know not exactly what the solution is, but does there exist a solution? This will be an existence proof. So we're told, well, we think that there is a solution, and we're going to call that x, but it's going to live between 1 and 2. So the proof is find the existence of a number that exists between 1 and 2 such that that number is a solution to this equation. So here we begin the formal proof. I'm going to put PF for proof to help me know that I'm starting my proof. We're going to take this equation and turn it into a function. So we say let f of x equal to the polynomial part of the equation, 4x cubed minus 6x squared plus 3x minus 2. So then we qualify what kind of function is this? F is a polynomial. And we've learned in previous modules that all polynomial functions are continuous on their domains, and domains of every polynomial function are the real numbers. So f is continuous. There's an abbreviation for continuous on, there's my double bar r, my shorthand for all real numbers. Now, we want to show that there is some number that would make this equal to 0. Well, let's think about that for a minute. Let's find f of 1. Because we were given the interval 1, 2, well, that's equal to 4 minus 6 plus 3 minus 2. And that turns out to be 7 minus 8, negative 1. And then we find f of 2, and that's equal to 32, because 4 times 8 is 32, minus 6 times 4 is 24, plus 3 times 2 is 6, minus 2. And if we add those numbers up, we get a 12. So let's just think for a minute what this means. We've got the interval 1, 2 on the x-axis. And when we evaluate f of 1, we get a negative value. Negative 1 is less than 0, and 12 is greater than 0. So we get a positive value. So it's up here someplace. And I don't know what the graph looks like in between those 2 points, but I know that f is a polynomial, so it is continuous, which means I have to draw some kind of curve leading from this point here to this point up here, and I can't have a gap or a jump or anything. The only way to do that is to cross the x-axis, and I have to cross the x-axis in between 1 and 2. I'm going to call this value on the x-axis c. That means that there is a c between 1 and 2 such that f of c is equal to 0. Well, that means this function is equal to 0, which means this equation is equal to 0 for when x is equal to c. So we can abbreviate IVT, the intermediate value theorem. There exists a c between 1 and 2 such that f of c is equal to 0, which means the equation has a solution. Now notice we're not finding the solution. This is merely the existence of a solution. Now that we've had this example and this explanation of the intermediate value theorem, you are ready to tackle those homework problems that are assigned with this module. Happy calculating!